Good morning. Next experiment is permeability test. The aim of this experiment to find the permeability of foundry sand. So now I would like to give brief introduction of this experiment. The purpose of conducting this experiment is to find that permeability of that sand. See, during that casting, when the molten metal is poured in the mold box, there will be an odd gases during the solidification. So that sand must be porous enough to allow the escape of hot gases and that water vapors during that solidification of the molten metal. So the property of permeability is most important for casting to avoid the defects like blowholes or pinholes. If you not provide such a porous of the sand, it may lead to that such a defects. So this permeability of sand, it is depends on that mainly grain size, binder and the degree of ramming and the water level present in that sand mixture. Now I would like to tell that brief procedure of this experiment. So first we need to prepare that specimen. So already we have discussed in that previous experiment while testing that hardness. Similarly, we need to prepare that specimen for that permeability test also. So after preparing that sand, the prepared sand we need to place on that orifice along with that specimen tube. Then we need to 200 cc of air is held on that inverted bell jar is forced to pass through that sand specimen. So after the air is passed through the specimen, completely note down that manometer readings. Here you can observe that manometer readings. So later I will show that individually. Based on that manometer readings, we need to calculate that permeability of that sand specimen using that chart. Then we need to repeat this experiment for the different ml of water content. First trial it is for 10 ml, next 15 ml and the third trial it is 20 ml. So like that we need to do. So now we'll start this experiment. So already we are prepared that specimen. You can observe here. You can observe that specimen here. Okay. So this specimen we are placing in that permeability device here. See, in this device you can observe it is showing that 0 here. If it is in 0, the load it is not applying. If we keep it for P, then it starts pressuring applying on this. Now we'll apply that load pressure on that jar. Then we need to set it for P for this applying load. We are setting for P. You can observe that it starts moving towards downward. That gases are escaping through that sand. Correspondingly, we need to take down that readings. Now we can observe that reading, that manometer reading. Here it is showing that 64. For 64, we need to calculate. We need to check that permeability number. You can observe that chart here, permeability chart. With respect to that pressure, we need to manometer reading. We need to take that permeability number. Here we have taken that 63 number, 6.3. For 6.3, the reading is 9.7. For smaller orifice, larger orifice it is 93. Similarly, so we have taken that it is that manometer reading for 10 ml, it is 7.5 and permeability number it is 63. Similarly, we need to do it for next two trials. we need to do it for next two trials, 15 ml and 20 ml. For 15 ml, we have got that manometer reading is 7.3, 6.67, and 20 ml of water, 7 manometer reading is 7, and permeability number is 75. Here you can observe that permeability number, if that water present is 10 ml of water present in that specimen, that permeability number is 63. Similarly, if the water content is increases, permeability number is getting decreases. Next, we need to write that result for 10 ml of water, that content, it is that permeability number 63, 15 ml 67, and 20 ml it is 75. Next, we need to draw that graph permeability number versus percentage of water content. We need to draw the graph permeability number versus percentage of water content in that present. You can observe here like this, we need to draw that graph percentage of water content versus permeability number. Thank you.